All right, so the last section in chapter 6, before we finish up and take a little mini test or mini quiz on this, is going to be solving linear inequalities. All right, so we're going to go through this kind of quickly because it's almost or is the same thing as solving equations, except for there's one little change that you guys have to make sure that you're aware of every time you go to solve. All right, so our objectives for today are going to be solving single-step linear inequalities. So it's just going to be solving where there's one thing that we need to do, multi-step linear inequalities, and then you'll need to know when to flip your inequality sign. Right? So that's the one thing that is different than when you're solving an equation. Everything else is exactly the same. All right, so let's go ahead and talk about a couple things first before we start solving anything. All right, so I'm going to just go through just one of the main things that you have to be aware of every time you're solving a linear inequality. So I'm giving you 4 statements, and all of these are true. 2 is greater than 1, 5 is less than or equal to 8, 3 is greater than or equal to 1, and 6 is less than 10. All right, we're going to talk about what happens. So let's take this 2 is greater than 1. What if I say let's add 5 to both sides? Plus 5, plus 5. 7 is still greater than 6. So when we're just adding numbers to both sides, nothing changes. It's still the exact same, or not that it's the exact same inequality, but it still holds true. So 2 was greater than 1, as long as if we're adding the same number to both sides, then we are still going to be greater on the left-hand side. 7 is still greater than 6. All right, the next one we have 5 is less than or equal to 8. Let's subtract 4 from both. So minus 4, minus 4. Well, 5 minus 4 is 1. 8 minus 4 is 4. It started out that our right-hand side was greater than our left, and it still is. 4 is still greater than or equal to 1. So when we're subtracting the same number from both sides, nothing really changes. It's still going to be the exact same inequality facing the same way. It's still going to be read 5 is less than or equal to 8. We're subtracting the same both. We're still less than on the left-hand side. Right? However, now we have 3 is greater than or equal to 1. Let's say that we want to multiply by negative 2. Well, 3 times negative 2 is negative 6. 1 times negative 2 is negative 2. It started out that our left-hand side was greater than. However, is negative 6 still greater than negative 2? No, it is now less than. So when we are multiplying by a negative number on both sides, so when we're multiplying both sides by a negative number, if you notice, it's going to change our inequality. We were actually greater than on the left-hand side, but after the multiplication, the right-hand side became greater than. So we actually had to flip it. All right, because when we did 3 times negative 2, that turned to negative 6. Well, 1 times negative 2 turned to negative 2. And our inequality, which was once the left-hand side was greater than, it now had to reverse. Our right-hand side is a greater side now. All right, if I do 6 is less than 10, let's divide by negative 2. All right, I know it just ends up being the same number that we just had, but let's just divide by negative 2. So divide by negative 2. Well, what happens when we divide by a negative number? Well, here we see 6 divided by negative 2 is equal to negative 3. 10 divided by negative 2 is negative 5. It started out that the right-hand side was greater, but now after we divide both sides by the same negative number, our inequality sign actually needs to flip because our right-hand side, negative 5, is no longer greater than negative 3. It's actually less than. So if you notice, whenever we're dividing both sides of our equation by the same negative number or multiplying both sides of the equation by the same negative number, we actually have to change or flip our inequality because it makes the opposite true. Because when we're dealing with positive numbers, the larger numbers are greater. But we're dealing with negative numbers, the smaller the negative number, it's actually greater than. Negative 2 is greater than negative 6. So when we're multiplying or dividing by the same negative number on both sides, we need to flip our inequality. Right? That is the main difference that we're doing when we're going through solving linear inequalities. That is the hardest thing that you will have to remember. Right? Everything else is the exact same thing that we just did the beginning part of this chapter with solving equations. All right, so let's go ahead. I think there's 4 questions we're going to solve. All right, when we're solving a linear inequality, so you see here we have a minus 4 is greater than 5. It's no longer like all the other ones we did where it was this a is greater than 5. We actually have some addition, some multiplication, some subtraction, division, anything is being done to it. So we need to do the exact same thing that we do for an equation is we isolate our variable. So the first thing that we're going to do is we need to put our variables on one side and our constants on the other. Unlike where we're dealing with equations, we can put our variables on both sides, I'm going to strongly advise that you put your variable on the left-hand side for an inequality because that's how we read the inequalities. So this can make it a little bit easier for you. All right, but if this was an equation, if I gave you a minus 4 is equal to 5, you would all know how to solve this. Let's add the 4, add the 4. So a is then equal to 9. So our steps are exactly the same thing. Nothing changes. We will add the 4 to both sides and add the 4 to both sides. So a is greater than 9 because as I showed you in that last part, when we're adding the same number to both sides or subtracting the same number to both sides, our inequality didn't change. What was once greater before was still greater. What was once less than was still less than. So now it just changes to the a is greater than 9. So if we were to graph this on a number line, I'm just going to show you, let's just pick a point, draw the number that we have, 9. All right, so since it's just greater than and not equal to, I know it's an open circle. And then since it's greater to, that means I'm going to draw all the numbers going on the right-hand side. If you're unsure which one you're going to draw, right or left, put a number, just one on the left-hand side and one on the right-hand side. And remember, our numbers go, we read and count from left to right. So we'll go 8, 9, 10. 10's greater than 9, so that means the line needs to be covering 10 and not 8. So going to the right. All right. Here, if we're going to be dividing by both sides. Now, I realized in the last page, I probably should have went through a couple more examples with you. So let me just go through it here. If I give you 9 is less than 12, and we divide each number by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. So our left-hand side was less than to begin with. It's still less than here. All right. The only time that we flip our inequality is not when we are just dividing or multiplying, but it's dividing or multiplying by a negative number. So here we're being multiplied to b. So we will then divide each side by 3. So b is then less than or equal to 3. All right. B is less than or equal to 3. When you're multiplying or dividing, it's only a negative number that flips. Right? So then here I can go ahead and put my number 3 anywhere on my number line. I'm going to put one number greater than and one number less than. It's equal to, so it's going to be a closed circle. It's less than, so that means I'm going to the left-hand side. So then this will be our final answer. Less than, b is less than or equal to negative, or less than or equal to 3. All right, so for this next one, we need to isolate our variable. So the first thing we'll do is we'll get rid of this positive 4. So as we talked about before, when it's a negative minusing both sides, it doesn't do anything. It's only in this step here. So now we have negative 2 being multiplied to our x. So now that we're dividing both sides by a negative number, the same negative number, we need to flip our inequality. So it was greater than, now it is less than. And negative 4 divided by negative 2 is positive 2. All right, so nothing changes when we're solving this, but there's one rule that you need to remember, that when you are dividing or multiplying by negative numbers only, you have to flip your inequality. All right, so if I were to graph this, I can pick 2, 3, and 1. It's just less than, not less than or equal to, so it's an open circle. Less than means we're going to the left, so there would be my solution. All right, there's one more example we're going to go through, and that's all. All right, so this one here, I just want to go through because fractions seem to confuse you guys. Since there's only one denominator, you don't have to use your LCM. In this case, you could if you wanted to. But since there's just one denominator, we can go ahead and isolate our variable. So we can then do plus 2 to both sides. So then we will get x over 4 is greater than or equal to 5. And then if we want to go ahead and solve for x, well, the fraction bar, this is saying x divided by 4. So the opposite of division is multiplication. So what I do to one side, I have to do to the other. And then these cancel out, and I'm left with x is greater than, let me write it over here, x is greater than or equal to 20. Since we are multiplying by a positive number, nothing changes. All right, so now I can go ahead and just write 20, 21, and 19. It is greater than or equal to, so it's going to be a closed circle at 20. And then since it's greater than, we're going to the right-hand side. All right, and then that will be it, and that is it for this chapter.